Okay, so we're going to look at modelling some trig equations. So this is the kind of situation where you're given a problem that you can see is going to need a sine or a cosine graph to model the situation, and we have to look at how we're going to go about solving that and how we can fit a model to our equation. So the example I'm going to use is from the book, from page 23, and it says, high tide at Piha is 4.6 metres at 10 a.m. and the low tide is 2.1 metres at 4:15 p.m. Form an equation based on times since midnight to model a tide and find a time when the water is 3 metres deep. So taking that information and starting it off, thing to remember is our basic function is a sine or cosine b, bracket x plus or minus c, plus or minus d. Okay, so with the example we've just been given, what do we know? Well, we know that high tide is 4.6 metres at 10 a.m. and that low tide is 2.1 metres at 4:15 p.m. Okay, so let's go through our different letters, our different variables. So A, first of all, that's our amplitude. So I need to know what's the height that it varies from. So I'm going from 4.6 metres to 2.1 metres. That's 2.5 metres, which means that my amplitude is half of that. So my amplitude I now know is 1.25 metres. Done. Okay, let's move on. Let's look at D. That's the next one that's obvious for me to do. How has the graph shifted up or down? Well, instead of going between 1 and -1, I'm going up to 4 and down to 2.1. So I need to find the midpoint between those two lines. So, halfway between 4.6 and 2.1. How do I do that? Well, the easiest way to do it is to find the average. Add up the two values and divide by 2. So add up 4.6 and 2.1, half the answer, and you get 3.35 metres. So that tells me the whole graph has shifted up to 3.5 metres. Okay, next one to look at, let's look at B, which is our period of our graph. So look at the period of the graph. Well, we know that high tide to low tide is between 10 a.m. and 4:15 p.m. Okay, so from high tide to low tide is 10 a.m. to 4:15 p.m., which is 6 hours and 15 minutes. Okay? Now, if you think about a sine or a cos graph, one cycle goes up, down, and back up again. So I need to know from high tide back to high tide again. So this is only half of the cycle. So that tells me that my full cycle is double that, which is 12 hours and 30 minutes. Okay, so how do I turn that into B? Well, remember, what we do is, that's 12.5 hours. So what we do is we take 2 pi and divide it by that cycle. That cycle's 12.5 hours, so that's 12.5. You can leave the answer as 2 pi divided by 12.5, but you know how I feel about putting decimals with fractions, so if it was me, I would convert that to be 4 pi over 25, just by doubling it. You don't have to, you can leave it as 2 pi over 12.5. Okay, so all that we're left now with is whether or not our graph has shifted. So now, and notice it's only now that I need to start deciding, am I going to use sine or am I going to use cosine? So that's the next thing I need to consider. Sine or cosine, and that will help me find C. Remember, the beginning of the question said, form an equation based on times since midnight. Okay, so just to summarise, I know that A is 1.25, B is 4 pi over 25, and D is 3.35. So at this point, I would be starting to draw a graph and starting to think about what it looks like. What do I know? Well, I know I don't need any negative values. What do I know? I know that the lowest point and the highest point for my high tides, and I know the midpoint is 3.35. So I know I need 2.1, 3.35 and 4.6 on my y-axis. And I know I'm graphing from midnight, so I need to start, so there's my centre line. I would always draw a dotted line in there just to help me out. I know that I'm starting at midnight, so a normal cycle, let's put in 24 hours. I might decide I need more than that, depends on my question, but I'm going to look at 24 hours. So from midnight to midnight. Okay, I know when my high tide is, and I know when my low tide is. So I can put those points in. I've got a high tide around about there, a low tide around about here. I also know that the time between high and low tides is 6 hours and 15 minutes. So if I've got a high tide at 10 a.m, I can work backwards from that and work out I've got a low tide at 3:45 in the morning. I've also got another high tide 6 hours and 15 minutes later, so I can draw a rough, dodgy sketch of what the graph is going to look like, something like that. So now that I know that, I can look at it and decide if I'm going to use sine or a cosine as my modelling. And from then, I can then look and decide what my shift is going to be. Now, the example in the book uses a sine graph. So therefore, looking at the sine graph, I need to find the midpoint. For me, I look at that and say, well, the first point I'm going to cross is a minimum. So that could be a cos graph, but it'll be a negative cos graph because I'm starting at the bottom, not starting at the top. You can choose to use sine, positive cos, or negative cos. It's up to you. For me, that is the most obvious. So I'm looking at this and going, well, there's a negative down here at 3 hours and 45 minutes. So my first low tide is at 3 hours and 45 minutes, which is 3.75 hours. So that means I'm going to use a negative cos. Okay, and that my C value is negative 3.75. So that gives me my function. I've now got negative, because it's a negative cos graph, A, 1.25, cos of B, 4 pi over 25. I'm going to put brackets around that just because it's complicated. Bracket x minus 3.75, close bracket, plus 3.35. So that's the model for my function. Done. Of course, now the good thing to do will be to draw it on your calculator so you can see what it looks like and just make sure it looks like you expect. I have a sketch above. When I draw it on my calculator, I want to make sure I see that, remembering to change your view window and everything so it all looks right and that you're in radians. Once I've done that, I'll go back to the question. If you remember, the question said I have to find when the water is 3 meters deep. So when I'm drawing that on the calculator, I'm going to draw a second line of y equals 3, and that will give me a horizontal line of 3 meters. Then I can use my G-solve and find the points of intersection. And the question asked me for any one of those, so any of the points of intersection would be fine, or I could perhaps find all of the places where the water is above 3 meters deep within a 24-hour period, or whatever the kind of solution I'm trying to find.